Okay, cool. Let's get started. Hello, everybody. We're back with episode 10 of Web3 Unleashed. It has been a long holiday break with like DevCon, Thanksgiving, things have come up. So it feels good to get back together, get the fam, MetaMask and Truffle here. For those of you who don't know, I'm Emily. I'm the developer advocate for Truffle. Today we have Christian and Guillaume from MetaMask Snaps. Would you guys like to introduce yourselves?
Yes, I'm Christian. I'm the product manager for MetaMask Snaps, and I've been with MetaMask since February.
And I'm Guillaume. I'm one of the engineers at MetaMask Snaps, and I've also been in MetaMask since February.
Okay, very cool. So I guess now that we've gotten that out of the way, let's go ahead and get started. Snaps overview. So what are snaps?
So Snaps is a platform that allows anyone to extend the functionality of MetaMask. And so it allows you to build features that integrate directly into MetaMask itself. And there's a lot of different features that you can build with this. And right now we have a developer build of MetaMask called MetaMask Flask, where you can start to play around with snaps and building and testing your snaps. And that's how you can see how the whole platform works and all of the APIs that are available.
Okay, cool. So can you tell me a little bit about like what the motivation for building snaps is or like was?
Yeah, so Snaps was actually an idea that came from our founder, Dan Finley. And it was, partly because there's so much innovation happening in Web3 and in the wallet space, and there's so many different proposals and ideas and different ways to implement things like account management, different ways to sign for different protocols and so forth. And it was just this realization that like one internal team cannot build all of the features and support all of the new innovation that's happening. And so instead of trying to keep up with the industry as a single team, there was this idea that if there was a way that other developers could come in and add features in a way that's safe and secure and decentralized, that would actually be much better for the industry and better for MetaMask itself. And so, they had this idea to build this platform and to make it possible for people to build programs that would run inside of MetaMask.
Yeah, I like this point you bring up a lot. So you gave a presentation on snaps in DevCon, and then you gave the presentation again on Tuesday in New York. For those of you who are in New York and you missed seeing us in person, boo on you, but thanks for joining the stream. You mentioned some statistic like, hey, audience guess, like what percent of what Apple applications are made by Apple?
Yeah. Yeah, so I was talking about like different types of modern platforms and how like Snaps can make, MetaMask itself into a modern platform. And one thing that I brought up was like, there's all of these applications on the iPhone, how many iPhone applications are actually made by Apple, right? Like Apple makes the iPhone, how many applications do they make? And, I always like to throw out this as something for people to guess. And sometimes people will guess like maybe 1% or 0.1% or something like that. There's over 4 million apps on the iPhone, and the number that are made by Apple is 0.001%. Like it's actually less than that. So it's like really a handful of applications that Apple makes. It's like stocks and the App Store and a few other things, right? It's like your health, your Apple Watch, whatever. And the same is true for like Chrome extensions. It's true for operating systems. Like the majority of the apps that we use every day are made by third parties. And when you think of like your iPhone and you think of like TikTok or Uber or something like that, you're thinking about a platform, with third-party developers that are delivering these like essential features that you think of when you think of these platforms.
Yeah, yeah. It's really crazy how small that number is because I don't know. Has anyone ever guessed it correctly? Because I think the numbers people throw out at first are like 20%, 10%, and it's just like,
No, it's always a surprise. I mean, it was a surprise to me when I was researching this, right? And if I keep giving examples, eventually people are like, oh, it's going to be 0.001% again, right? Because it always ends up being less than that. So after a while, people get it. But on first guess, it's not what you would think of, and part of
right.
it is like, it's hard to really quantify like how much innovation is happening that is throughout the ecosystem and not coming from even like the biggest players in the space.
Right, right. That's really exciting. I think applying that paradigm to MetaMask. I don't know. I'm very bullish on this. So, snaps are great for MetaMask though. So what about our devs out there? Why should they be building a snap?
I mean, we get a lot of inquiries from developers who are working on new proposals or new technology. And they're always asking, how could this be added into wallets, right? And so if you're a developer today and you're building a new feature, like a new way to do ZK proofs, or, maybe you have an Ethereum compatible, and a network that's compatible with Ethereum, but it has some extra features that don't already exist on Ethereum, right? And in order for you to get that adopted, the wallets have to support it, right? But the way to get wallets to support it is you basically have to go to each wallet and ask them, like, are they willing to build this feature? And every wallet has a team behind it, and that team is already swamped with all the things that they're trying to do. They have a roadmap of features, and if you ask them, they'll say, not anytime soon, right? Like the likelihood of us supporting this is not going to come right away. So a lot of developers end up having to build their own wallets or build their own extensions, and the path for adopting stuff like that is very difficult, right? And it's like users then ask us like, well, why doesn't MetaMask support this? And it's like, well, we can't support everything, right? Internally, that's just too much effort, right? So this really changes things for developers because they have a path to get features at the wallet level that is much quicker and with a lot less hurdles. And it also, because it's sandboxed and modular, you can build a snap, and that snap is a repository that you control. You have your own like update path, you have your own versioning, and you're not dependent on like every new release of the MetaMask extension itself is somehow affecting your code, right? And we're so excited about supporting developers in this area, and obviously the success of this depends on the success of developers as well, that we've actually put together a grants program. So it's called the MetaMask Grants DAO, and it's a DAO because it's actually an internal DAO within Consensus. Like Consensus employees can vote on the various grants, and it's all driven by employees. And if you go to metamaskgrants.org, you can actually apply for grants. And one of the main topic areas is snaps, right? So if you're building a snap and you're looking for a grant to help support, let's say, your security review or your development or so forth, you can actually apply for that through this grants DAO.
Yeah, I know, like, at least on the DevRel team, we've really been pushing snaps at, like, hackathons and stuff. Have you guys heard of any really cool snaps kind of examples out in the wild, whether that be a hackathon or I know there's a Starknet snap that came out, so maybe, like, company sponsored, kind of give people a idea of the possibilities that could happen.
Yeah, we've actually seen some snaps, and I want Guillaume to answer this one after me too, but we've seen some really interesting snaps. And one thing that's really cool is we've seen developers build snaps for other hackathons that weren't like our own hackathon. So like we've gone to events like ETH Lisbon, ETH Bogota, and so forth, and we've run our own hackathons where the prompts are, build a snap, right? But we've seen people build snaps for other hackathons, and they've actually, in some cases, won awards for these snaps. And one of the ones that I saw that was really cool was a snap that would essentially build like a registry of smart contracts. And like it actually, the project included a database and a dApp and a snap, right? And so it would build a registry of smart contracts. And then the snap would show you if you were interacting with a smart contract that was known to be malicious, right? And so it was cool how they thought about the different parts of how you would build this. And they built like an end-to-end solution. So it wasn't just the snap that notifies you of the contract being dangerous, but also all of the like infrastructure for tracking these smart contracts. Guillaume, did you have a favorite one?
I don't have a favorite one, but I guess we've seen some pretty good TX Insight snaps in hackathons, and I feel like this is something that could really be useful for users. So yeah, that's maybe the topic where I see the most useful snaps coming.
Yeah, and that
Yeah.
was like the motivation behind building this box, right? And helping people be able to test these types of snaps much easier.
Yeah.
Yeah. So the project we'll be building today is going to be a transaction inside Snaps. But yeah, it is super cool. I think the idea, like one of the biggest pieces I think people are always talking about now in Web3 adoption is like security, UX, helping people understand what's going on, and transaction insights definitely a really powerful hook into that. I think it's funny too. This is like kind of a side story for our viewers. There's another guy on the Snaps team. His name is Frederick. He built like basically the first transaction snaps, uh, and got like super. He blew up on Twitter. He was telling me, he's like, Emily, I'm becoming more popular than you. And I
Yeah.
was like,
Well,
yeah, it definitely makes sense. This is a huge use case that is way more important than like whatever I produce. So like,
yeah, well, he embedded Ganache in a snap, and that was really exciting because we had all been talking about like if you could embed Ganache inside of a snap, then you could like do all kinds of cool simulation stuff. But we weren't expecting someone to build it, and he was like, he just came in one Monday and he was like, "Oh, I built this over the weekend," and of course it was everybody was super excited about it because everybody like understood that, oh, that's really powerful if you can do that.
yeah. So that was really fun. So obviously that I didn't know that people were independently building snaps at hackathons. That's really interesting because I was going to ask you, like, snaps launched this year, right? And how has the reception been, I guess, since?
Yeah, well, the main thing was that MetaMask Flask was launched at the beginning of this year, right? So that actually gave people a way to build snaps and test them and be able to deploy them. And so with Flask, we don't recommend that like the average like everyday user installs it. It's just for developers. But among those developers, they've been able to like try out each other's snaps and actually like see how they work. And so since then, we've had a bunch of developers who just started building them by going through our documentation and just experimenting, and they've already built all kinds of features. So we've probably had like more than 30, maybe 50 or so snaps have come out of these hackathons, but there's
Mm.
probably another 50 or so that have been developed independently. Just people, you know, in the ecosystem who have just started playing with this and wanted to build something with it.
Yeah. Okay, cool. And then maybe just general question for both of you guys as people who work on the wallets team. Where do you see the future of wallets?
Yeah, so for me, I'll say that like, you know, things like sign in with Ethereum are really interesting. Wallets being not just your way of interacting with the blockchain, but your way of managing your identity and be able to like carry information with you and do it in a way that's secure. And you have the ability to opt in to when you share information about yourself. And so we're seeing this paradigm shift of like people thinking about, well, my wallet is not just like a crypto thing or an assets thing, but it's actually my identity and it carries my information and it can do that in a way that's more secure. Like I have control over it because it's self custodial. So I think that dApp developers are starting to build around this concept. And we're seeing social services like Lens and Farcaster that are seeing the wallet as like your core identity and authentication manager and building really cool things on top of that that are not about like making money or financial, you know, assets. It's not DeFi, it's like another area of like portable distributed computing that is like really interesting for people.
Okay. Super cool.
Guillaume?
Yeah, I guess um, I would say I want to see wallets become more permissionless. And I guess that's why I'm working with Snap, because we are basically trying to push for permissionless innovations and a way to extend wallets without having to ask for like anybody.
Yeah. Okay, cool. So that was our overview. Now we'll dive into kind of the technical portion of Snaps. So now, Christian, you can sit there awkwardly and smile. And yeah, you can take the stage. Cool. So basically, how does a snap work? You know, that's a super broad question. I know it can get super deep, but just like if you could
Yeah,
try and scratch the surface.
so basically, a snaps work by like running a piece of code inside a secure container in MetaMask. We've been using some pretty cool technologies like SES, so Secure ECMAScript, which is a subset of JavaScript, which allows you to lock down some features of JavaScript and freeze everything. And so it allows us to run this code inside MetaMask. And using an API that we provide, it allows you to interact and extend the capabilities of the wallet. And at the same time, it allows you to create a new API that can be called by any dApps via an RPC methods. And if I want to keep it concise, that's where I want to stop.
Okay, cool. Yeah, when we go through building a dApp a snap together, you can like maybe
Yeah.
jump in and explain the different pieces. Kind of, I guess, question about, just getting snaps implemented. What were the technical challenges you guys had to face?
I guess the one that is on top of my head is keeping Snap permissionless. That's one thing that is really hard to get, because obviously you want to empower people to do whatever they want, but you need to provide a way to do it securely.
Okay, yeah. So that kind of fed into my next question, and I think you touched on this too. So guaranteeing Snap security is through, you said, SES.
Hmm. That's the base layer of Snap security. Um, SES allows us to, as I said, lock down what is running inside MetaMask, um, and also, uh, yeah, that's basically the main layer of security of Snaps. But also, the permission system allows you to easily see what a Snap will be able to do. So
Mm,
that means that when you install Snap, there is predefined permissions asked by the Snap itself that you can review and allow or disallow, if you depending on, well, what you want to do.
okay. Okay, cool. Yes. When I was building a Snap, I did see those coming in. Hopefully, though, we won't get too long, because I can imagine, one of those sometimes apps ask you for permissions and you just like scroll through a bunch of them and then you hit submit at the end. I feel like that's like the next step in like potential security implications. Like everybody read the permissions before going in. But actually on that note too, I guess I heard this question asked in a few ways in the multiple iterations of the, I guess, presentations I've seen you guys give, Christian, but like talking about Snap security in regards to a potential like marketplace. What is MetaMask going to do on our side to vet that, snaps can be downloaded, or are they just out there in the wild, buyer beware?
Yeah, that one's a good question. Like one part of it is like because we're building this open permissionless system, like we're not trying to be sort of like the deciding factor in the success of Snap. So we're not trying to build a marketplace similar to what you see other companies do, where essentially they're picking and curating like which developers end up succeeding, right? So that's not something that we want to do. And initially, the way you distribute a Snap is by you publish a dApp and you invite people to come and connect and install your Snap, right? So that being said, one thing that we are working on is ways that users can curate and recommend snaps, and ways that we can enable that and make that useful. And also, when we release the first version of the API next year, we're still working out the whole security model. So initially, we're going with an allow list approach. So we're just going to allow certain snaps to be installed that we've already like had independently reviewed, and we know that they're safe to use. But over time, we're going to enable more permissionless innovation to be possible, and enable more ways for users to recommend snaps and have ways of tracking these.
Cool. Here's a question from Jose. In the future, could snaps be wallet agnostic?
Yeah, so that's definitely possible, and a big part of it is, if other wallets choose to implement, something like Snaps and choose to support, this sort of like approach. Right now, this is something that is unique to MetaMask, and something that we're moving very quickly on because we think it's very important to have this feature available in the market. But definitely, if someone else wants to implement something like this, they could do that.
Cool. And then I guess I had like a leading question just for users to know. mobile versus desktop experience for snaps. What is it? What does it look like?
Yeah, so we do plan to support snaps on mobile. That's going to come later. And interestingly enough, we're building it in such a way that the API will be consistent across both platforms. So the idea will be that if you write a snap, it will work within, Google Chrome and Mozilla Firefox and so forth. Like it'll work within the extension on your desktop browser, and it'll work within our mobile app, and you won't have to write two sets of code. The API for you as the Snaps developer will be the same.
Oh, that's sick. Okay, cool. So I guess something I always like to ask my attendees is, any upcoming plans, specifically alpha. I guess we work at the same company, so I should know, but can you any hints? Or I mean, it doesn't have to be alpha. What's upcoming? I guess you said mobile.
Yeah, mobile support is one. Another one that's really cool is we're revamping our documentation. So we're going to have many more, like much better documentation of the Snaps API and ways that you can play around with it. And we're working on this concept called custom UI. So we're eventually going to have these dialogues. Like right now, we have these custom confirmations, and you can see them in our template snap, like a little pop up that has like header, title, description. But we're going to have one that allows you to do much more flexible. Like you can put in different content, you can use a little bit of markdown and everything, and that's really nice for building like cohesive user interfaces. And that'll be existing in dialogues as well as in transaction insights. And then one other thing is that we're going to have this cron jobs API, which is going to land very soon, which allows you to do scheduled actions. So you could have a snap that say runs periodically and collects information from say the OpenSea NFT API, and then gives you notifications like, hey, your item just sold, or someone made an offer on your item, or so forth, and you'll get that information right inside of MetaMask.
Very cool. Very cool. Okay. If you have any links or resources to get started, please send them my way. I'll blast them in the chat. Otherwise, I'm gonna, I guess, ask if there's any questions to interrupt now. I know not everyone's necessarily live, and there's a bit of a lag. So I'll count to 5, and if there's no questions within 5 seconds after I start counting, we'll dive into the builders portion. And you guys can watch me crash and burn and help me debug live. These are the 2 links that Guillaume and Christian sent me. Okay, so questions. 5, 4, 3, 2, 1. Okay, cool. I'm gonna start sharing my screen. That means I will not be able to see what's going on. If anything comes up in the chat, let me know. Christian, Guillaume, you can see the side chat, right, with all the...
Yeah.
Yeah, okay, cool. Share my screen. Let's get started. So the motivation for today was basically we are building, or I guess Guillaume and Christian built a truffle box, right? So for those of you who aren't familiar with truffle boxes, I'll just say it again. Truffle boxes are essentially like scaffold or boilerplate code to help you get started with projects as fast as possible. In this specific case, they helped us build a snap box, which will basically set you up to create a snap with a site as well as a package for storing all of your contracts. I'll show that in code so it makes way more sense than just me verbalizing it right now. And so to get a truffle box, you just do a truffle unbox, and the box's name is called MetaMask snap-box. I'm going to put it in a directory. We'll call it MetaMask snap demo. Hopefully I haven't used this name before. Cool. And I'm going to open that up and start playing around with it. So the first thing you need to do when you get into this box is you're going to do a yarn install and a yarn start. So while that's going, I'll just step through the different pieces in this box, and Christian and Guillaume, please feel to interrupt me anytime I say something wrong.
You should just zoom in a little bit.
Okay. I already made a mistake in the beginning. Thanks. No, I'm just kidding. Starting from the top, the things to note that are the most important is going to be what we're putting in packages. So packages, we have site, snap, and truffle. So pretty self-explanatory. Site is going to be where you're going to store the front end for your dApp. That's going to be where you're connecting to your Snap, interacting with it, sending in those methods to connect with the Snap. Snap is actually going to be the code where the Snap code lives. So if you want to dive into this a little bit deeper, this is kind of the base file that you're going to edit to actually start editing your Snap code. In the most simple case, so in the Snap box, it does this thing where it's using the snap confirm method. So specifically, this allows you to interrupt the transaction to send a message within a snap. So to show you what that looks like, oh, I already have, whoops. Okay, there we go. Now I can probably do a yarn start again. Sorry, I had something running at the same port. So if that is running, let's go to my local host 8000. Nope, did not go. Oh, okay. Oh, here we go. Cool. So this is what it looks like, basically. Do note you have to download MetaMask Flask. So as Christian had mentioned, there's a, I guess it's like the canary version of MetaMask development. Do not use this in production. But other thing to note is if you have MetaMask, your normal wallet, and MetaMask Flask on the same browser, this is not going to work. It's going to get confused. So what you have to do is either disable your normal MetaMask, which is what I did here, or you can create a new Chrome profile and then click add and then download your Flask there, import your wallet, and then use it like that. So that was like a mistake I ran into when I was trying to build this. I could not figure out why there's like 2 lines, I think, in the doc that say like don't have it at the same time. Like you could have made this a little bit bigger, but that's also my fault for not reading. But anyways, so basically to go through connect, this is one of the permissions is displaying a confirmation in MetaMask. So once I hit approve, this is the example snap. As you can see, it kind of interrupted right here and just said, hey, you can do this edit snap code, and all of that code lives here. And so that's the base snap that exists here. Other things that are going to be important to your snap is this manifest. Specifically, what we're going to be modifying in our snap today is this permission thing. So as Guillaume and Christian had touched upon during our interview portion, one of the ways that we're guaranteeing security is making sure it's very specific what we are giving you and not giving you access to. Otherwise, Truffle is pretty self-explanatory. That's where the contracts live. One thing in this box that's kind of neato burrito is there's an included Ganache script. So Ganache is going to be your local test chain. So as you're building, starting up this box will actually also start up an instance of Ganache for you. Caveat to note though, so it will start up in here. You will need to actually copy paste these keys and save them off, because once you lose that screen, you will have no way to access your secret keys or mnemonic again for security purposes. So save that off. If you want to have to avoid doing that, you can also put in your own mnemonic phrase so that I'll keep bringing it up the same way every time. Other options too are Ganache has like a DB path where you can persist transactions. All of that lives in the documentation. It's in the tutorial that I'll post up later. But just also another disclaimer, please copy paste that off because we'll be using those wallets to interact with. And also to note, this script actually brings up a fork of mainnet. So that means if you want, you can interact with contracts that exist on mainnet as well. We did this because not every snap necessarily works with a contract that you write. This is a Truffle podcast, so obviously we're writing contract to pair with it, but there's a lot of snaps that actually don't have a Solidity component to it at all. But yeah, so that's kind of a brief summary. I don't know if you guys had anything else you wanted to add about the box, if I misrepresented anything. I don't see you on my screen, so say yes or no.
Yeah, it's like you said, you can build snaps with contracts, or you can also just run Ganache, out of the Truffle package and use it to test against existing contracts, right? So if you're building a transaction inside Snap, you probably want to test against a lot of contracts, and you can do that and they'll have the same address that they have on mainnet. So you can just get the addresses from Etherscan or something and just test them locally this way.
Yep. Cool. Okay, so let's get started. Today we're going to be building a DApp called an NFT vault. So basically, what the NFT vault structure is going to look like is I, as a user, have the ability to deposit NFTs from my wallet into this vault for more secure storage. And in order to withdraw it, it requires a second signer to do that approval. So that I can't just like willy-nilly withdraw it either. Very simple. The point here more so is to demonstrate how we can hook a snap into that flow to help identify, who the withdrawer is, who the approvals are, things like that. Let's actually get started into building the contracts first. So I'm going to go into Truffle, packages, Truffle, and then we're going to create, oh, whoops, I already have this. Whoops. Okay. We're going to create 2 contracts and a test because test-driven development is really important. So after that's created, you should be able to see in here, we have NFT Vault, Simple NFT, and a test for NFT Vault. Simple NFT is just going to be a test. I guess what do you call it?
Like a very simple NFT contract.
Yeah. So it's right. It's not important here. We're just using it for testing purposes to make it easy. If you've followed our other live streams before, you should be very familiar with what this contract looks like. Essentially inherits the ERC 721. We implement the mint function with a monotonically increasing token ID. If you saw what I just did there, I was just importing or adding the Open Zeppelin contracts package as well as the test helper for writing our tests. So simple NFT. I'll dive into the NFT Vault contract because that's the one that we'll actually be working with. That's a little bit more interesting. So I'll just copy and paste that code here. So going from the top, we are going to be importing the Open Zeppelin interface because throughout this Vault process, we want to transfer it. So that means we'll be needing to call specific functions on the ERC 721. To get those functions, we're importing the Open Zeppelin interface. Here, basically, we have 2 variables we're defining. The approval struct. So this is basically a object that will contain 3 pieces of information. Number 1, the address of the owner of the NFT, address of the second signer of the NFT. So when I do the deposit, who am I assigning as a person to sign the withdrawal? And the last piece is a Boolean approved. So you can imagine if this is true, then it can be withdrawn. If it is false, it'll fail. In order to store that information, we are storing a contract variable called approvals. It's a mapping of NFT contract address to the NFT ID to the approval properties of it. So stepping down, first thing we do is deposit. So pretty straightforward, just takes in whatever your NFT is going to be. So that's identified by the contract and the token ID, as well as the second signer. We don't want to deposit twice, so we are right here setting a require method to essentially check that owner is 0 address. So in Solidity, when there's like nothing in a mapping, for example, the value you'll get returned is going to be default values. So in this case, the default value for an address is a 0 address. The default value for a Boolean is false. So that's how we're doing the checking here. Otherwise, we assign, I guess, what we expect, message.sender. So that's going to be the caller of deposit NFT. They're the one doing the depositing and then actually transferring from the user or the owner of the NFT to this, which is going to be the NFT vault contract. One thing to note that's going to be a common gotcha. In order to do transfers of NFTs, the address actually needs to have approval to do so. In this case, the NFT vault contract address doesn't have approval. So this would actually fail unless you beforehand give it approval to do that. So in our actual flow, so both in the tests and in the actual DApp building process, I'll show you how to actually add an approval for the NFT vault to take in that NFT to deposit and therefore call this function. Because otherwise this will fail. Anyways, moving forward, withdraw NFT, also pretty straightforward, essentially getting the NFT data, and then, oh my God, checking 3 things. First off, that it exists. So that's the not equals address 0. Making sure that the person withdrawing it is the owner, and then checking that approved is true. And so approved will be true when the second signer has called approve withdraw, which you can find right here. And then provided all that's true, you do the transfer, and then we'll remove that NFT from the list of approvals. 2 things to note, or 1 thing to note here, we have approval memory data versus approval storage data. If you guys aren't familiar with Solidity either, when we are pulling out these structs, we actually need to specify whether or not it's going to be stored in memory or stored in storage. So this is going to be with structs. This is also with strings. Basically decides whether or not a change to this piece of information will be persisted. So in this case, because it's memory, if I change this to like data.owner equals blah, 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 that won't get persisted. However, in this case, storage, when I do change approved to be true, that will get persisted. This will spend some gas. In both of these cases, these are considered write functions, right? So moving on to get approval. So get approval is just going to be the only read function of this contract. You can tell this because there's a view and a returns. And all it does is it returns the information about a specific NFT. Another thing to know is you cannot return structs as one of the values for a, what do you call it? For a contract address, or sorry, not contract address, a method. So in this case, we had to get around it by using an array here. So address bool, that's going to be owner, second signer, approved. And the last piece here, removing approval, pretty straightforward. It's basically the same thing as approve withdraw. Get the storage. Make sure that the person actually removing the approval or doing the approval is the second signer, and then setting that to false. Cool. So that's all there is. The next thing we need to do in our contract writing process is we need to do the deployment. So deploy contracts. Let me copy some, paste some code here. So this is just where you tell Truffle how you want to deploy it. It's super simple. These NFTs or these contracts don't depend on each other. We're only deploying it to one chain. So that's the extent of our migration contract. And last piece, this one's hefty, so I'm going to copy paste this code here. It's the test. I'm also not going to go into too much detail because we're all here for snaps and not here for Truffle. Hopefully you've been to my other streams and you know how to do all of this already. I'm just going to delete these 2. But NFT Vault, so essentially, right, this is going to be our contract. Important things to note out here for this test is we are using OpenZeppelin test helpers. This is specifically to help us make sure all of those required statements are properly failing. And so we do that by using OpenZeppelin's expect revert. So if a require fails, Solidity will revert that function and OpenZeppelin's check that. Constants is just going to give us like constant abstractions for like the 0 address, ETH, etc. But yeah, anyways, moving forward, 2 utility functions here, mint NFT. So we'll be working with NFTs throughout the entire test. I just set aside a simple function to help us like mint NFTs throughout the entire time. Asserting the approval is basically making sure that approval information, so owner, second signer approved, is all correct. And then getting into the actual test. So note that this test is written in JavaScript. You have the option to write it in TypeScript as well as Solidity. I chose JavaScript tests because that's the easiest for me. One thing to note here, basically, is before every test, we are going to be minting and depositing a NFT to work with. What I called out before, if you notice specifically here, is we need to send an approve call. So essentially, approve is a function that is on the ERC 721, and it basically says, hey, for this contract address, I want to approve the NFT vault address to be able to do transfers. And so if this was not here, deposit NFT would fail. And so that's included here. But otherwise, just going through the tests, right? So making sure that it should deposit. We expect, the token owner and second signer approved to be all these values. Same thing here. Here's an example of using expect revert. And then moving forward, kind of looks like that. And so I didn't do anything wrong. Should be a Truffle test, and it should compile, and everything should run. And yay! Okay, great. That is awesome. Now we can move on into building the snap and the dApp. So in order to do that, we're going to have to do one thing, and we're going to have to modify the Truffle config. So all of this was running on a test instance, right? But to migrate it onto our actual development network, which we have started up here, we have to run a real Truffle migrate. The other piece to it is, as we build our dApp, we want to be able to interact with that information. So we will change this contracts build directory to build into the snap source folder. So I'm going to just do a snap source contracts. Cool. So if I do a Truffle migrate, which will default to the development network, you should see in here that it created the contracts. And this gives you all the information like the ABIs and the network addresses and everything like that. And so now that we have it, we can start playing around. So we'll go into the site building portion first. I'm not actually going to go into like building the site step by step. It's just going to be a lot of React. I'm hoping you guys know React. That's not so, because we're going to dive into the snap building more in depth. So go into your sites package. We're going to need a yarn add ethers. And we can go into, basically all we need to do is modify this front page. So essentially on this page, we're going to remove the send hello card and then add a bunch of cards that will take us through each of the different NFT Vault contract functions that I had stepped through before. So I'm just going to go ahead and copy paste all of that code because it is also a lot and I don't want to, what do you call it?
It's very repetitive and boring too.
It's, yeah, it's repetitive and boring to watch. Or feel free to leave a comment and say you like watching me copy paste things, and I'll reconsider my work process. But okay, let me grab this code. Copy. Wow, amazing. Look how much coding I got done. First thing to note is this is in TypeScript, but I really didn't bother with fixing any of the type errors, so there are going to be a lot of red squiggly lines. But things to note that are important is we imported ethers in order to start interacting with those JSON files with all of the contract build information. You import it as so from the snap source contracts folder. And then we had also added a use state and a use effect. Specifically, when we dive into the actual code, you can note here that in order to interact with our contracts, we are getting the contract address and the interface. And in order to get the address, we have to dive into that ABI, or sorry, that JSON file, get the network ID, and then index into it. So I can pull up actually, if you look in Truffle, and then simple NFT vault, and you can grab the deployments networks right here. We are deploying to a Ganache instance that is forking mainnet. So that means the network ID is 1, which matches the network ID of mainnet. And so going back here, as you can see, basically to get that network ID, we are doing a window.ethereum request, getting the net version, and then running the effect. And then every time that chain changes, i.e. the network ID changes, we'll want to reset that. And provided there were multiple networks being deployed, then it would choose between those. But anyways, that's the address. And then the other portion that we want to care about, just to kind of highlight over, is if you look actually calling the, making the contract call. If you guys have done development before, you might be familiar with stuff like ethers.contract and using those methods instead of like doing this funky wonky like function data. This is pretty cool because it'll actually show you the like hex data string, which will be relevant for when we actually build a snap and decoding it. So that's kind of this right here. But as you can see, it's encoding the function data, and then passing it through via send transaction. So I'm not going to dive into the site anymore because that's not the most interesting part. I'm just going to hope it updated properly. Yes. See, look, it works. And all the cards are here. So the mint, approve it, deposit, approve, to withdraw, and withdraw it. Okay. Oh, that's a lot. Okay, let's dive into the snap building portion. This is where you guys hopefully won't sit in silence and be like, "Oh, you should explain this." And then
We're still here. Don't worry.
yeah. Okay, cool. Nice. So to actually get this started, we are building a transaction insight snap. So that specifically means that we want to give MetaMask approval to read the transaction payload so that we can play around with it. In order to do that, we have to go to our manifest file and add the, what is it called?
The endowment.
Endowments. I can't find the thing. Okay, let me see if I can get the code from somewhere. Endowment transaction insight. Okay, cool. I found it. Yeah, so this is basically, again, a permission that it gives you the ability to read the payload. So that's what you need to modify there. Otherwise, going into the actual code here as well, we're going to need to modify the transaction TS config. So in this specific case, as I mentioned, we want to be interacting with those JSON files built by Truffle. Because of some Gatsby compilation stuff, we actually have to set this to true for the code to be able to recognize that we are importing these JSON files. That'll make more sense once I actually do it, but that needs to go there. Otherwise, this is still site. We'll go to index. So this was the request handler for the hello world. We don't need that anymore. We're actually going to be working with the transaction handler. So we're just going to copy paste that here like this. And what that code looks like is going to be super straightforward. Here. So basically, when this is called, it'll call the on-transaction handler. This is the payload. And then we will be decoding that payload to get insights into our snap. So that is that. We can actually move into creating that insights file. So insights TS. Cool. And I forgot, we also need to add some packages in order for all of this to work. So just go into your snap folder and we're going to download these guys, utils, stuff like that. Okay, so let's start out with the very bare bones of this project. So in this insight, I copy paste here. We haven't used everything yet, but what you can see again is we are pulling in that JSON data to get the contract addresses. Thing to note here, in our site, you might be familiar with using window.ethereum. Within a snap, the equivalent is just going to be this wallet. So instead of window.ethereum.request, we have wallet.request net version. And then this is just getting the contract addresses. The next piece here then is like once we get this transaction data, basically we can switch between who are the contract that we're looking at. So is it the simple NFT? Then we will return this. If it's the NFT vault contract, it'll be this guy. Otherwise, I don't recognize it. So hopefully all of that worked because I didn't test any of it in between. Anytime you change the snap, you will have to reconnect. So I'm going to hit approve and install. Oh, actually, I am in an account with 0 money. So let me remove this because that was from an old Ganache instance. So back to that import account. So it's really important that you should have copy pasted this. Grab that secret key. And look, I'm so rich. Okay. And then you can connect the account. Cool. So let's reconnect.
When you install, you'll see there's another permission. If you click reconnect again.
Oh,
now
yeah.
There's 2 permissions.
Cool. So yeah, I guess I should also mimic being a smart, what do you call it? consumer of digital products and actually read permissions. So slow
That's
down.
the important stuff. Yeah, that's your opportunity to
That's
opt
probably
in.
the most important part of this tutorial, honestly. But as you can see, now we have a new tab here, Transaction Snap, and it would have clicked up the contract address and said, "You're interacting," and now we see it. Yay! Okay, cool. So I minted an NFT just now. Next piece is we actually want to get this a little bit more complex. So what if we don't only want to know what contract we're working with, but actually want to start like decoding into the methods, right? So I'm going to add in this code right here. And what this does is basically gets the function signature, which is received from here, and basically switches between these different, I guess, numbers. So again, with Solidity, when it's calling functions, it actually encodes it where like the first 4 bytes are actually what identifies the function name and types. And so that's what we're switching across on here. And so now, again, because we updated it, we can hit reconnect, approve and install. So in this case, we minted an NFT. So now we need to approve the NFT to be withdrawn. So to get that, we need to get the, whoops, this is not the correct package. We need to get the contract address. So to do that, we can just simply go here. And it was 1, hit approve, confirm. And now we can do the deposit. So here's 1, here's that. And then let's get a second signer in as well. So let's import another account. And then where is that? Okay. Import account. Yeah. Okay. I'll connect that for later. And then deposit. Cool. So if you look at this, now you can see deposit NFT has worked. And I want to
You have to
proceed
switch back
anyways.
to the first account.
Oh,
You can't. Yeah.
yep, you're right. Thank you. This is why I need you in my life, Christian.
Here to help.
Thank you. Okay, cool. And hit confirm, and it should have deposited. Yay! And then the last piece of the snap, and this is a really interesting piece, is actually, so we've decoded the methods. Now we're actually going to decode the arguments, or like the actual information. So in order to do this, we have this nifty thing called 4-byte value, which is just going to decode the hex data into a beautiful string that everyone can understand. And then now at the end of this, add another piece. And so this is actually now going to be decoding the arguments and the data. So we said if it's NFT vault, if it's withdraw NFT. This is again just kind of figuring out how to manipulate that transaction data, but eventually getting to the point where it's like, oh, okay, well now we know the types. And then see here, where is this? We're actually going to be getting the vault contract to get the approval object so that we can also display who the second signer is, who the owner is, the approved status, and demonstrate that, which is pretty interesting. So again, to go back, we have to next hit approve and install. And all of this should be, I'll do it without approving it first. So if you can see right here, I'm going to withdraw. Right? And if you look here, we can't withdraw. This was me, the owner, the second signer, and it's false. So that's all the information that came from the snap, which is pretty cool, right? So in order to make this work, then we can switch accounts, copy, paste. Oh, nope, we're not copy paste that. Approve withdrawal. As before, you can see this information, hit confirm. Once that's approved, it'll take a little bit of time. It'll be faster than mainnet, but slower than vanilla Ganache because it is forking mainnet.
It's cheaper than
Just
mainnet
interesting.
too.
Cheaper than mainnet, yes. And then now we're back here. So if we hit withdraw, and it should say yes. And that is all there is to building a snap. I think cool things to note, tricks here. I actually don't know how to debug in MetaMask snaps, but if you have trouble kind of like throughout this process, you can actually connect your what do you call it? Ganache instance to your VS Code. And so throughout this entire process, we could actually dive into all of the code that we had been interacting with through our DApp. And then like kind of step through and step in. And then I'm assuming debugging a snap too, so it would be like a console log kind of thing.
Yeah, it's actually really difficult. You can use console.log. The errors are often hard to understand. We actually have a task to make the error reporting better. So we're doing a lot of work on improving this. But you know, if you run into issues, you can always just go to our discussion board and ask us or hop in the Discord and let us know and we'll help.
Oh no, there were so many comments. Can you plus font size? Hopefully it was big enough.
Oh, that's when I told you to zoom in. Yeah.
Okay. The rug pull function is missing. Jose's
Yeah,
like
it's
he's
missing
funny.
from the NFT contract.
Yeah.
That was a joke. Yeah.
You can build that in. I will just never use your contract.
Make a PR. So
Um,
one thing I was gonna say is like there's different ways you could improve this. Like you could make the NFT vault take a Merkle root or whatever, right? You could have like different ways of handling the approval. And the snap, you know, this was just like a contrived example to show how a snap could read on-chain data and actually interact with contracts. But you could think of some really cool things like maybe you had a snap that can identify any like NFT contract, and when you go to mint, it tells you how much supply is left, you know, or it could like warn you if like the NFTs can't be transferred, right? So there's all kinds of cool stuff once you learn how to like use ethers from within a snap and connect to the wallet and actually like read on-chain data.
Okay, cool. I'm just typing up a response. Jose mentioned console log greater than debugging tools. I completely agree. This is great for beginners. One thing I think, what do you call it? People had trouble with Truffle at first because we didn't have console log. We now do. So exciting. We'll be talking about it on our Truffle community call on Monday, actually. So for those of you who are interested, 11 a.m. EST. We're doing a Truffle Wrapped, basically going through all the things we built in 2022. A lot has changed. But yeah, is there anyone? Are there any questions? Christian, Guillaume, you don't have anything to insert? Or I just did everything perfectly, apparently?
You did a great job.
Apparently, yes.
Definitely. Great. Thanks for helping us build this too.
No, yeah. I mean, it was all Christian and Guillaume, guys. They are the, like, I guess, MVPs of this project. Like, I felt bad because I just kind of pushed all the code to the main GitHub repository, and I was like, oh, none of this attributes it to Christian Montoya's GitHub handle. But the truth of it is, he was the originator. But yeah.
Yeah, Guillaume figured out how to put the packages together, right? So that was so cool because it was like I had told them like I want a way to test smart contracts and snaps, and they like made it work. So yeah. Oh, and definitely for that question, check out the job openings on the Consensus website.
Yep. Well, Snap's team is my second favorite team at Consensus other than Truffle. So followed by
the other teams.
Yeah. I shouldn't say this publicly. Though at some level I'm like, am I fishing? So other people will be like, Emily, what can we do to make you our best or favorite team? That's just me being toxic is what it is. Okay, cool. So I have to hop up because I actually have a Twitter space to attend. But everybody, thank you for joining. This will be posted online shortly later today, or tomorrow morning. But yeah, it was really good having you guys.
Thank you for having us.
Yeah.
Thank
Have
you.
a good Thursday.
Bye.
Bye.
Bye.